Raycast suspension. There was no good tutorials. Since then, there hasn't been any new tutorials, and I wanted to make one where I really go over the ideas instead of just showing code for people to copy. So, before coding, I just want to go over the ideas. So, suspension helps keep each wheel in contact with the ground by applying forces that react to bumps, dips, and motion. In Roblox, we simulate this using raycasts, springs, and dampers, all done in code. What's needed? A loop that runs every physics step that gives time between steps. A way to loop through every single wheel. Access to wheel start position and last spring length. And these are the base equations. These are really complicated, but I'll just go over it either way. So the spring length is going to be equal to raycast distance minus wheel radius if there is a raycast. If there's no raycast, if the raycast didn't hit, then you just spring length just equals max spring length. And max spring length is a constant that you set. Displacement is max spring length minus spring length, which is this right here. And then velocity is the change over length over change in time. Which change over length is the spring length value of the current time step minus the spring length value of the last time step. This is Hooke's law with damper added to it. So it's spring force equals displacement multiplied by stiffness minus velocity multiplied by damper. Stiffness and damper are constants. So these might be a little complicated, but these right here are easy to see and understand. I'm sorry about this. I don't know how to, the red underline, I don't know how to fix this. I'm gonna just leave it. Spring length equals if raycast, then raycast distance minus, or you know what, let me do this. Raycast dot distance minus wheel radius, else max spring length. Displacement equals max spring length minus spring length. Spring velocity equals spring length minus last spring length divided by delta time. Spring force equals displacement multiplied by stiffness minus spring velocity multiplied by damper. And this is what it would look like in code. Pretty easy, pretty simple. And you'd have to do this for every single wheel, by the way. And you know, I'm gonna go over the code. I'm gonna do the whole thing in front of you. All right, this is the car structure. You have the model. You got to make sure the primary part of the model is the chassis, which is just a part. The body folder, right? You don't really need to have it in a folder named body. It's not really important. It's just to keep the car clean. This is where the visual parts of the car are stored. Everything here must be welded to the chassis. The only thing that's important is having every part welded to. Okay, this is incorrect. You just got to make sure you have it welded to the chassis. Okay, this is the car structure. So first you have the model. Just got to make sure the primary part is the chassis, which is just a part. You have the body folder. This is not really needed. It's just to help keep the code clean. This is where the visual parts of the car is stored. Everything here must be welded to the chassis. No, the only important part is having the parts welded. Everything else is to keep your car model clean. This is important. The wheels folder. This is where the wheels are stored. I have them named FR for front right and BL for back left. So it's easy to access the parts. And none of the parts should be welded to anything. And just make sure that they are anchored. And then this is a very important part. This is the main part of the car where the forces are applied. It can be the shape of the car body or just a plain 3x8x1 part. This is what it looks like, a valid structure. This is the base car with no body. This is the only thing required to make the car work. And this video is only going to be going over suspension. I'm not going to be going over the driving forces or friction forces. I'll do that in another video. So, I'm gonna just, I showed this, which is basically just a base model of a car. So I'm gonna do a somewhat complex model. I'm gonna just use a toolbox car. So I'm gonna go here. I'm gonna search a car. This one is probably the easiest to clean up and do. So I'm gonna do this. So I'm gonna rename this the car, and I'm gonna delete the script in driver's seat. I'm gonna select all the wheels, group as folder, and folder wheels. And then, so they already have the chassis, as you can see. The chassis is like the main part of the car. At the bottom, and everything else is really just a part of the body. So this is what I'm gonna do. Thrusters, I think, is only used by the code. I'm gonna delete that configuration. I'm gonna delete that. And I'm gonna delete the lights. And then I'm gonna group everything together except the chassis, and I'm gonna group this folder. I'm gonna select everything as well, just to delete what's ever in here, because I'm not gonna need it. The same for here. And here as well. And then I'm gonna rename the wheels so it's easier to access. You can have it named whatever you want, honestly. It's just I feel like BL, BR, FL, and FR are the easiest to do. So I'm gonna use them. I gotta also make sure they're anchored. And I gotta weld these. I don't know if okay, I don't have a welding plugin downloaded, so I'm gonna just make my own welding script. So first we gotta loop through every single part under the body body script or body folder. So I'm going to do this. So I don't really have to use get descendants, but if you're just copying what I'm doing and your body folder is not as clean as this, it might, it might have another folder like this, right? Where it has even more parts. And if I were to use get children, number one, it's going to pick up that folder and not everything inside that folder. And number two, well, no, I'm not gonna lie, that's really it. So then you gotta check if the part that you're looking at is even a base part. Like, can it even be welded to anything? So if V is a base part, then you make a weld. So local weld equals, for instance, new weld constraint. Make sure it's a weld constraint, not a weld instance. You want to make sure the parent is the part itself. The well.p0 is going to be equal to the part in the well.p1 is going to be equal to workspace.r chassis. You can take the script and just paste it to the console, and boom, you got all the weld constraints, which is perfect. So we can delete this console, clear this, delete the script. That's really it for the preparing the model. You can also do something else to prepare it, I guess. You can add vector forces and attachments. I'm gonna be doing that through the script though. So I'll just put this in. I'm gonna leave this in workspace, and I'm gonna just have the script and script service. I'm gonna create a script and I'll access the car. So if we look, first thing that we need to do is a way to loop through every single wheel, which the best way to do that is using a for I loop, for IV loop. And in order to do that, we need a table that has every single wheel. So, and also we need a wheel access to the wheel start position and last spring length. Okay, so I'm gonna just make a table, blank table called wheels, and I need to initialize every wheel. So to do that, I'm gonna just loop through this right here. So for ID, or I'm gonna just for part in. This just basically means that you're not using I, so you know it's left blank. You can do I or whatever. It's not really useful. For part, let me just make sure this is part. In car dot wheels, get children. Dude. So right now, it's gonna loop through every single part, and we're gonna start the. That's how we're gonna store it, and then so number one we need part, and then we need the last spring length and the start position. So last spring length equals 1, or yeah, I'm just leave it as 1. That's fine. And we need access to the start position. So there's 2 ways to do this. One way is getting the offset and using it later on, and the second way is using an attachment. I feel like the attachment is the best option because regardless, you're gonna need the attachment for the vector forces instance. So to do this, I'm gonna say attachment equals instance new attachment, and I'm gonna make sure the part is going to be the attachment parent is going to be the chassis, which I'm gonna say car dot primary part. And I just want to double check. Okay, I don't have this set, so there we go. Now we need to make sure that the attachment is put in the right place. So just gonna set that real quick by doing this. World cframe equals part.cframe. Once you set it once, it's always gonna be there, which is nice. So yeah. And we need one more thing, and that's going to be a vector force instance. Vector force equals instance new vector force. Parent, I'm gonna make it part.chassis. Alright. Now we need to set some values of it. So we need to set the value, the force value. We need to set the attachment value. We need to set the relative to value. I think that's it for now. So okay. So dot force equals dot 0. Relative to equals world. Attachment 0 is going to be equal to the attachment that we have made. That should really be it for preparing the model and the wheels table. I'm gonna just test this out real quick just to make sure everything works. And if we look at it, yep, perfect. Yeah, okay. So this works perfectly good. This works perfectly fine. Next thing to do is have a loop that runs every physics step, which Roblox has, and that's called heartbeat. So I'm gonna say game dot one service dot heartbeat connect function, and it gives us delta time, past the delta time, so we can just save that. We're gonna need it for the spring velocity. And now we need to loop through every single wheel. So okay, so for wheel name, wheel info, in wheels 2. Okay, so first thing that we need to do is get the spring length, which we're gonna need to do by getting the raycast. So let's do that. So local raycast position equals, you can say wheel info dot attachment dot world position. Local raycast distance equals oh yeah, we need some configs. Okay, so we're gonna do the local spring length equals 1. Local max stiffness equals 1000. Local damper equals 100. And we also need the wheel radius. So wheel radius equals so to get the radius, you just gotta look at your wheel part, any of them, and there's gonna be two values that are close together and one value that's far away from the other two. So you're just gonna copy one of the two values that is close together and divide it by 2, which 3 divided by 2 is 1.5. So that's the wheel radius. And the raycast distance is going to be the max spring length plus wheel radius. Local raycast direction. The raycast direction is just going to be the car chassis down vector. So, which is negative up vector. We'll make sure that is the unit of that. So, yeah, that's. You also need the raycast param. So I'm just make that real quick. So this is just going to be telling the raycast that to ignore any part underneath the car model. So, for example, the raycast won't hit the wheels or the body or the chassis. So, yeah. Now we have all these values. We can make the raycast. So local raycast equals workspace raycast position, then raycast direction multiplied by the raycast distance. We give raycast parameter that we've made. Now to extract the spring length, we can just copy the code over here. Local spring length, if there's raycast, then raycast.distance minus wheel radius, else max spring length. Displacement, well, I mean, yeah, I could just copy. I'm not going to copy though. So local displacement is going to equal the max spring length minus spring length. The next thing you need is going to be the velocity. So local spring velocity equals. Let's see if this is correct. Spring length minus, yeah. So this is correct. The spring length minus the last spring length divided by delta time. And now let's calculate the damper force. The damper force equals negative spring velocity multiplied by damper. So doing negative, if you look over here, I have a minus over here, but since I'm doing negative spring velocity, I can do plus. And then local stiffness force equals, it's not negative displacement, it's just displacement multiplied by stiffness. And then finally, the local spring force equals damper force plus Stiffness force, yeah. And this is actually correct. And this is correct. Wow. Is this correct? Let's see if I remember. This is not correct. But let me edit this real quick. Um, we're gonna say wheel info attachment.world C frame to world space C frame new. And then this one's gonna be negative spin. So usually what people would do over here when setting the for, because this is just a number, so you need to make it, you need to turn it into a vector. Most people are gonna do this. You multiply it by the up vector of the car. Issue with that is if you're on a slope, the car is gonna push off the slope, and I'm gonna show that. And then we gotta set the last spring length so the car can use the damper and stabilize. And the C-frame is just the starting point. You offset it by the spring length on the y-axis relative to the car's down vector, which is why you use the world space of the attachment C-frame. So if everything's done correct, it should work. Let's see. Okay, so first let's debug a little bit. I just want to make sure that the script itself is working. So you can see it's working perfectly fine. Yeah. I'll just make it smoother. Do that. You can see it's working very nice. Next thing to see is the, yeah, that's perfect. It should be going up. Yeah, so from what I'm getting is that the script is working perfectly fine. It's just the issue with the values that I have over here. Is it the assembly mass? It's probably the assembly mass. I'm gonna just make everything here massless. There we go. Yeah, you see? Yeah, so you can see that the car slides off, which we don't want. I want it to stay in position, which the easiest way to do that is taking the spring force, multiplying it by the y-axis, which is 0, 1, 0. Now if we test that out, perfect. Yeah. So that's really it. There's some things, so let me see if I can show you guys. There might be some problems with your value. That's where the main, if you followed everything correctly, your car is not working. It is 100% the values. Let me see if what happens if I make this not massless. Where is the massless? Okay. And then I should have like assembly mass somewhere. 80, 98. I'll make this a high value like 5,000. There we go. And even that is not like, good enough. But the way you change the values are obviously going to affect how the car is. It's very fun to play around with the values. Yeah, look at that. That's very nice. Let me increase the spring length to 4. Yeah, I love gas cars, man. It's so satisfying to me. Look at that. And yeah, I hope you enjoyed the tutorial. If you have any criticism, comment it. If you have any questions, I'm gonna make a Discord server, my YouTube channel. If you have any questions, you can just join or ask it in the comments. And yeah, thank you for watching, and I hope you learned something.